Hello, everyone. Hi, Bettina.
Hey, good morning, Alex. Good morning, everybody. Very good to see you all.
Yeah, great day
Thanks very
today.
much.
Great day today. We
It's
have
a,
last day, last workshop of
it's
this
the
very long
last.
series. Yes, it's the last. It's hard to believe it was such a long way, and now we have all these people still with us. That's great. That's amazing.
Thank you so much for being with us throughout the whole 8 weeks. That's the 16th workshop for us today, and it's the grand finale where we bring our application to the cloud, and we have some theory for you today and some practicals where we show you how this actually works, porting the application to cloud.
Yeah,
So thanks very much for joining us.
Yeah, today is very special topic. Today we work on a really application into the cloud, and we are going to do a lot of things with Google Compute Platform, and to be more specific, Google Kubernetes Engine, but also with some other services as well. And just few words before we start. So that's Bentina Sunertan, our developer advocate, and maybe you've seen me already, Aleksandr VOLOCHNEV, developer advocate as well. But behind us, there is a very big team, so don't think like there are only two people for you, but all the developer advocates special unit here to help you, depending on their time
And
zones.
let's not forget our other helpers from DataStax, right? We very often get Yoshi from Japan and Jeremy from Australia helping us as well. So a big thank you to those who help answering questions on Discord and YouTube. So thanks very much.
Yep.
Good. So let's review. Where did we start? Look how far we've come, right? So first we were weeks 1 and 2, where we covered the Apache Cassandra fundamentals and data modeling. And we asked you to do a lot of work in terms of video watching and reviewing. Then we put some of it into practice by building CRUD services, REST microservices in week 3 and 4 in several languages, mainly Java and Python. We then took you on a real sort of like tour de force, showing you what Cassandra looks like in Kubernetes, introducing these new concepts to some, or to a lot of people, new concepts like Docker and Kubernetes, and then how we use the Cas operator to manage Cassandra in Kubernetes. We then showed you how to deploy our application into Kubernetes. We Dockerized our UI and our backend. We rolled it out. We connected to Astra and to the Kubernetes Cassandra installation that we had managed by the Cas operator. And last week, David and team, we showed you all the various methods that you have to stress test your application, simulate load, simulate data in order to understand how it actually behaves under load. And this week, we want to make your applications really cloud native. So let's go away from the development system that we use with Kind and really roll it into the cloud and make it publicly accessible so you can share it with your friends and let them play with this application and connect to Astra. And today we are going to do this in a Google Cloud platform as an example. There are other opportunities and other solutions available, but we just had to stick one for the example. We had to choose one, and we do not ask you to do it with us at the same time because there are setup steps involved, but we give you all the instructions so that you can do it in your own time after the workshop.
Yep, and
Okay.
don't be afraid to do it after the workshop. Like so many people are trying to do it live while we are showing something, and they are distracted. Why? Because we're afraid we will not help them after the workshop is done, and that's wrong. We have community.datastacks.com, we have Discord, so even if you are doing exercises after the workshop, you still completely may have our help.
Absolutely. We are here to help you, and we're here to help you live now. But as Alex said, after the workshop, we can stay on Discord. I personally like it when you put your questions into community.datastacks.com because then other people can learn from your questions and from your answers, and we have a little bit more of a reference. But these avenues are totally available for you if you want help after the workshop. And please ask us. Yeah, we want you to be trying this out and develop your own applications. So we're looking forward to that. Good. I think we really need to address this early on and probably a few times during the workshop. Certification vouchers. A lot of people are really, really keen on getting these vouchers and what needs to happen so you get them. So in order to get a voucher, you will receive early next week an email with your coupon, right? Oops. So make sure that you fill in the form that's required, that comes with the email, so you can request this coupon. So it's, yeah, don't miss this step. Look out for the email. If you don't get the email, you can always get in touch with us on Discord, especially, or email Jack Fryer directly. So we want to help you. You will not miss out on your coupon, okay? Okay, so let's have a look. So we're streaming today on YouTube and Twitch. There were a couple of technical issues in the workshop that we did yesterday, so bear with us if we run into this again. Let us know if this font is too small, if you're not seeing it properly, or if the screen is frozen. That happened a few times yesterday. We will want to work on it and get it right for you. We stream on Twitch as well. We answer your questions, YouTube, Discord, and as said before, you can always go to community. We will be using Astra today, but very, very little, just to complete our full demo cycle where we enter our details through the UI in our example. But other than that, we don't use Astra very much today. And all the instructions are published on GitHub for today, and we've put a lot of screenshots in there. So hopefully you find it easy to follow along if you do it after the workshop. And let's go into a cloud computing overview where we present you basically what is cloud and what do we mean by that? What are the terminology? And this is a common joke. There isn't really any cloud, right? It's just someone else's computer. It's someone else's hardware installation, data center, all managed for you. So.
Oh, that's a sorry. Mm-hmm.
So the big thing about cloud is that you basically have computer system resources at your fingertips. It's on demand, it's available, and it's usually actually really affordable. And you do not have the management overhead. So you do not need to take care of power supplies, cooling, installation, upgrades, and management and all these kind of things. So it's something that was first created by Amazon and it has become famous as Amazon Web Services with their first elastic cloud computing. And now we have several players, and the biggest are Amazon and Microsoft with Azure and Google Cloud Platform, and these are the three that we go into more details. There are others, and I'm sure there will be others in the future because this is really a growing marketplace. The principles are, it is on demand. It is self-service. You do not have to talk to a salesperson to get access. It's usually very publicly available with good network access. It's very elastic. You can scale it horizontally, vertically in terms, and you can scale it down. It is very, very fair pricing. Typically, it's really what you use, and it comes off as well with that you're sharing the resources. You're basically getting time slices or slices of larger computing resources. And so this is other people that might be using exactly the same machine at the same time. And this sharing is all managed by the cloud provider. And the advantages, really cost savings. It might appear expensive, right? But if you compare it with buying the hardware yourself, installing it, managing, etc., you really can get access to some very powerful resources at a fraction of the cost that you would need to have spent sort of like 10 years ago in order to have it on premise. Security is solved for you. It's very flexible. It's accessible from lots of different places. Disaster recovery is handled. There's guards again against data loss and catastrophic losses of your applications, the updates, and often you have a lot of different monitoring and logging solutions that help you to gain insight into what is actually happening in this, what is ultimately a remote resource, right? So these are the biggest advantages.
Yeah. From my side, I would add a little bit, like from my professional background, I would add for most of the companies we communicated regarding the clouds, the biggest benefits were first, like imagine you have 1 or 2 times per year like the highest amount of consumers, of clients, like I don't know if it's a e-commerce, we can speak of a Black Friday and then Christmas and all the things like that. So you have the highest pressure and a lot of visitors, but in the other days the amount of pressure of on your production may be 3 times less or 4 times less. But you have to be ready to work with all these Black Fridays and whatever events happening. You have to be ready all the time. So basically you are paying, you are or not having enough infrastructure to handle Black Friday, or you have too powerful infrastructure for the most of the time. So clouds give us some very serious elasticness. Today I want to have 1000 application servers running. Boom, I have them. And tomorrow I don't need them anymore because, I don't know, it's Sunday and everyone is sleeping, and boom, and I have 200 application servers and I'm not paying for these 800. That's amazing. That's first thing. And second thing, what also... go on, please.
And usually you can spin this up very quickly, right? You do not have to plan this a month and ahead and say, on that Sunday I will need extra resource. No, you can just go and add it in. Right?
Yeah, well, of course, it depends on the workload and kind of the servers you are working with. But in general, yes, if you did everything right, then it should be spawnable and decommissioned in just some seconds. Then second point was, it was just really cool for us, for very many clients. It was just great the possibility to have data center in a very far away city, to have some deployments in a completely different country, in the United States, if we are speaking about Europe, or in Australia, and we can have our data center and applications where with ease, with no problems, deploying any kind of applications all over the world. Beforehand, with mostly on-premises things, or at least manually manageable servers, it was not so easy to organize. So that was the best features from our side.
Cool. So deployment models is just a couple of terms, really. So public cloud is basically what we just sort of like started to cover. Private cloud, it's also common, right? So that you organize your on-premise resources in such a way that they function like a cloud for you. They're almost like a remote cloud, but they're all under private management. Hybrid cloud, where you mix those two approaches and potentially, for example, deploy your Cassandra database into both these clouds. Multi-cloud, same reason. You don't necessarily want to be just put all your eggs into one basket and just be on AWS. You might want to be on some other clouds as well in order to minimize the risk of a single vendor. So these are different terms that you might come across when talking about clouds. And it's worth asking the questions, right? What do you really mean, right? What kind of... And as I just sort of mentioned, Cassandra fits very well into these deployments because we already have the concept of the data center that allows you, to deploy into different regions, into different availability zones, or into different clouds. So it fits really well, this model. And then to take it a little bit further, drill in to demystify the whole term of cloud, there are different aspects of the clouds that you might want to use. Right, and there are a couple of terms that come up in this context. One is infrastructure as a service, which really relates to the infrastructure, the networking architecture, everything related really to your bare metal hardware installations. Then we have platform as a service, which is one level up, which is already has the runtimes in order to run your applications, that has the various languages installed. So at the operating system. So it has the middleware, it has the additional layers that you need in order to provide, to deploy your application. And then on top is something that we actually use every day in our daily lives now, is software as a service. If you think about all the different cloud services that you might use, that we're using at the moment, we have GitHub, we have Google email, we have Google Drive, we might use Spotify and photo applications. All these are examples of software as a service. Or for example, DataStax Astra is software as a service. That is at that layer. Everything is handled for you. You just bring your own usage. You're the user, you bring your data, you bring your configuration perhaps, but you do not need to take care of the management and all the plumbing underneath in order to make that to work. So there's a couple more examples. As I said, AWS, Azure, Google Cloud Platforms are currently the biggest players in the infrastructure as a service, but there are Rackspace is in there, so there's other providers, and I'm sure there will be more. Then in the application stack here, we've got App Engine, for example. We've got Elastic Beanstalk. We've got Heroku, which I believe is part of Salesforce, OpenShift, etc. So these are examples of the platform as a service. And then, the examples for software as a service, they're really, really countless. We have a lot of them.
Okay. Bettina, I would like to make 3 very, very simple and short examples. So if it's not going so easy for you, I want to explain in just a couple of words. Infrastructure as a service cloud provider is when you go to this cloud provider and tell, give me a server in this Europe West 1, Frankfurt or whatever, Paris, and I will deploy my operating system, I will put my own application, and it will work with my clients. So you ask for, okay, that's a good slide as well. So we've...
Exactly, yeah. Just keep talking, Alex.
Yeah. That's wonderful. So for infrastructure as a service, you ask for a server. When with platform as a service, you say, this is my application, cloud provider, please put it somewhere. And when I will work with this application and my clients will work with this application. So you don't care of the operating system, any runtime things. You care about your application there. And then software as a service, then you just consuming something what delivered by our company. Like in our example, you can run Cassandra on your own with whatever your data center you are using, but you also can go to Astra, and Astra is a Cassandra as a service. In this case, you don't care of the servers, you don't care of the operating systems, you don't care of the application of the Cassandra by itself. It's taken care by DataStax. So that's the best example of software as a service.
Okay, thank you. Mm-hmm. Thank you very much for making it clearer. So, and this is just don't get your glasses out. This is not meant to be read. It's just sort of shows you a little bit the variety. It's what is available in these clouds and in these offerings. So it's huge, and I'm sure it's growing.
Bettina, there is a very good question in YouTube chat. Can we call GitHub PaaS, platform as a service? No, GitHub is exactly the example of software as a service because it hosts GitHub repositories. So when you communicate with software as a service, you use API of this software. In this case, we use Git to work with GitHub. And GitHub could have been a platform as a service, but in this case, you should be the one to install something on this platform. So you would be the one to install like Git mirror repo there and take care of that. So no, GitHub is a very good example of software as a service.
Exactly. And also, I think these storage solutions like S3 or Google Storage, these are all software as a service, right? Google Drive, because you don't deal with any of the runtimes underneath or the the operating system. So you're basically using a fully configured application, right? You still bring your own data and your own usage. Yeah, that's absolutely fine, right? But it is really already software as a service. That's why I think it's actually so much part of our daily lives now. We don't even recognize this anymore, right? So there's another term, containers as a service, which you didn't have in the pyramid before, but it kind of sits on top of the platform as a service, where there are certain services here like virtualization and DevOps tools like Chef, and then the various components that we require in order to successfully deploy containers, right? So Kubernetes and Docker, for example. And so let's go into a little bit the different providers, and we will zoom in on AWS, Azure, and Google Cloud Platform. We cannot cover everything. These are the biggest. You see, I mean, Amazon has by far the biggest market share. Amazon had a real head start in compared to everybody else. They started early, something 7 years ahead of people. Microsoft sort of came up as the next player and has caught up quite a bit. Google and Alibaba, for example, that's really growing. And then there's there are more coming up. But that's really the picture how it looks today. And the revenue is, there is a lot of revenue basically in this offering, and I think it will attract more players, but Amazon is really dominating, then again, Microsoft, Google, and the other players. And what is interesting here, that is mainly infrastructure as a service and software as a service that are really bringing in the main revenue. So platform as a service, that's sort of growing slowly. It's growing, but we anticipate that with how popular Kubernetes is getting, that this will increase in the future. So let's talk a little bit about AWS. So all the cloud providers publish their availability zones and regions, as a benefit to you in terms of to bring your availability zone close to your application and close to what you want to be doing, but also as a sort of like to demonstrate the spread and power of their application or of their offering. And so it's, mainly North America, and you see that Africa and South America, we see this picture everywhere, that this is really lagging behind, but we expect changes. This might already, I think someone picked us up yesterday in the workshop that this is already a little bit out of date, and there might actually be a different picture already. So things are growing, things are coming. Currently, you can get access to 219 services in AWS. I'm sure this will also increase, but it's a lot. You have a lot of different services and tools at your fingertips. So this is what it looks like when you log into the AWS Cloud console, and it gives you an idea of the various services that are available. And for example, storage, where S3 sits in this area, database services, analytics services, tools, whatever, so we are, probably most interested in the compute services and the storage, but the world is your oyster with these things, so you can really explore and get lost in the variety that you have there.
Exactly, and don't think like that's all of the services or what AWS provides. Those are groups of the services.
Exactly.
For example, we speak of a storage as it's like our data stack's professional interest. And when we speak about AWS storage, there is a Glacier, there is an S3, and many others actually. So there are different kind of storages for different kind of purposes. And for every group you are seeing on the screen, there will be definitely some services inside. So altogether, it's like up to 300 different services at this moment.
Exactly. So there's a couple that you should know, we think. Personally, I haven't really worked that much with AWS, but I've certainly come across those services. I mean, first of all, this is the one to configure, to get your instances, infrastructure as a service, Elastic Compute Cloud, EC2, Elastic Beanstalk. I haven't worked with this at all, but this is the platform as a service offering to deploy your applications. Then something that Alex will cover later is functions as a service, which are serverless functions, cloud functions, where you do not need to have any infrastructure at all in order to run those functions. We all know S3, I think. If you don't, for example, the images for the VMs that you get for the DataStax Academy courses, you basically download them from S3. So this is a very simple, accessible storage. Then we have different networking solutions. The virtual private cloud is probably the most prominent there. And then, of course, for the purpose of our workshop here, what is important is the Kubernetes service and the container service. And you will see that a lot of the Amazon services are prefixed with Elastic. So you have Elastic storage, you have Elastic services, Elastic Analytics, these kind of things. And then, how would that look with Cassandra on AWS? So, and it's basically different layers again of ease of management. So you can just do it all yourself. You get EC2 instances and you install Cassandra. These are just Linux boxes. You put Cassandra on them, you manage everything yourself. You can get pre-built images where you do not need to install it yourself. So you can just basically just deploy the image. You can get it from the Amazon Marketplace. We used to offer DataStax Managed Service for Cassandra. We now prefer that you go to Astra, so that as a more convenient offering on AWS instances. Amazon has also their own Cassandra or SQL compliant Cassandra-like database offering, which is Amazon Key Spaces. You can use our drivers, for example, the Cassandra drivers to connect to them. And then in the container as a service, you can use the Cass operator in the Elastic Kubernetes service and deploy your Cassandra instances this way.
Yep. One thing to add, people often ask like, okay, so many ways to use Cassandra in the cloud on AWS, so what's the best one? And there is no simple answer because it very depends on your company approach, on your project, on your workload, how many qualified engineers do you have. If you are a startup maybe and you don't have so many engineers, you may maybe go with Astra because it's like the smallest amount of efforts to make your database running. You click the button, you have Cassandra, and DataStax engineers, so very qualified people, will take care of that. But for some companies, it may be they want exactly opposite, to go as deep as possible and have 100% full own control. And then they can go with infrastructure as a service and have their Linux machines there and set up everything, including like very deeps of Linux networking, and have full control and have the deepest whatever configuration they want to have with Cassandra and Linux and whatever application they are using. So there is no simple answer, and like it very depends on your situation.
Yeah. I mean, you could, for example, in here, that allows you to install a Cassandra version that you forked, right? Or you have your own, or an out-of-date version that is still in use, in your company. So, so you have the most flexibility here, but the trade-off is you have the management overhead.
Yep.
Versus here, it's been made much easier for you, or here, right? So it's depends. It really depends on your circumstances. Okay, Azure, same picture for Azure. What's the spread, right? What regions, availability zones? It's a similar picture to what we saw with AWS. And in fact, I don't think we will see significantly different picture for Google Cloud. So this has a little bit more traction in Africa at the moment. So it's came on later, 4 years after AWS, but it's catching up. The console looks very similar. You have, it looks different, but it's sort of like the function is similar. You have basically groups of different services that you can access. Again, you probably want the ability to get your instances up, but then you have a lot of different things that you can plug in and additional abstraction in order to make your life easier. So very similar. Again, it's something I haven't really worked with very much. And when I prepared the demo for this workshop, I have most experience with Google Cloud Platform, so I just chose Google Cloud Platform for the demo. all this you should be able to do it all in these different clouds as well.
The general idea is the same, and that's technically one of the benefits of Kubernetes. So you may have multiple clouds within the single Kubernetes cluster. It's not going to be easy to manage, frankly speaking, but it may bring you some benefits if you know what you are doing.
Exactly. And then you get the same services, you get the machines, get your instances, the infrastructure as a service, they have an app service, again, you have serverless functions, you have Kubernetes services, the cloud, the container support, different storage options, again, sort of like blob storage for simple storage as we know it from S3. For example, we have all the networking services that we would expect and need, very similar and similarly named to what we have from AWS. And Azure also have, or Microsoft, they also have a SQL compliant database, Cosmos. So again, you can access it via the Cassandra drivers, but the underlying implementation is not Cassandra, so it looks different.
Just for the record, people ask us, is there Cosmos DB a Cassandra? The answer is no, Cosmos DB is not Cassandra, but it supports some features of SQL.
Exactly. And then if you want to deploy Cassandra on Azure, it's exactly the same picture as before. You have these different layers of abstraction and where the management is taken for you. Again, you can do it with just the instances, install entirely your version of Cassandra that you want to have. We again have pre-built images. We can get managed services from the marketplace, or, I'm not entirely sure whether we offer this still, but we have customers who use DataStax managed services. You can get Astra on Azure. It's currently in beta stage, but we're working on deploying it fully. You get the Cassandra-ish access via Cosmos, and you can again deploy via the CAS operator in this case Azure Kubernetes service. Oops, that was the wrong. Okay, now Google Cloud. It's again a similar picture. So it's just it's the youngest kid on the block. Started in 2008. Has not quite as many regions and availability zones probably as AWS, but it's coming up. Lots of different services. It's growing. This is a very growing field, and I think personally, when I started to look into Google Cloud, this was for me the most confusing aspect. Is all these different services and the flexibility that you have. It's really a combinatorial challenge of like combining these different services and which one to use for which purpose. So it can really take some time to sort of like go through all these different solutions and decide what is best for you. So they're pretty strong in analytics and machine learning and the big data support, and those two things working together to get the most out of your data that you store there. So there's a lot of interesting stuff happening in Google Cloud and constantly adding more services in order to support these different applications and use cases. We will really concentrate on this layer here. We will use the Kubernetes engine today. And that in turn uses the compute engine in order to spin up the instances that we need. And we will actually also very briefly touch a little bit on the cloud storage. So you get an idea of how to manage your work in Google Cloud Platform and keep an eye on the billing and the costs. So I basically touch in the demo a little bit on that. The 10 services that you should definitely know. Again, compute engine, these are your instances. Application engine, if you want to very quickly deploy apps, serverless functions, and the Kubernetes engine. And we will be really exploring that today. Then the different storage options that you have, the different networking options that you have. And Google BigQuery is very popular, and the integration is made very easy. For example, if you really wanted, you could just export your billing into BigQuery and analyze it there and really work out where does the cost go where if you have a really big deployment in Google Cloud Platform. Okay. And then similar, as before, I think it's really by design, right? So those three cloud offerings really don't give you any. You can deploy a Cassandra in similar ways on all those three, right? So you have the very basic access by getting the compute engines, then you have the marketplace launcher. You have the ability to use it as a managed service. You can use Astra targeting Google Cloud, and you can also directly connect to Astra from the Google Cloud console. So, and then what we are doing today, actually, we're not going to demonstrate the use of the CAS operator in Google Cloud Engine today, but you could, if you wanted to, take the exercise a step further and connect your application again back to a locally within the cloud installed Cassandra cluster.
Yep, and I would say it's not a bug, but a feature, and moreover, a very, very good feature. So, for example, we mentioned that in the beginning, but haven't explained it. You can go multi-cloud, and we usually mention like disaster tolerance or things like that, but that can be another point of view, like on some clouds, some kinds of workloads must be significantly cheaper than on others, and then you can prefer to do some kinds of workloads at the one cloud and do another kind of workloads in another cloud, and just to save your money. And sometimes cloud bills are really, really, really heavy. So in this case, we will work today at the cloud application. So application we worked at last week, but we will deploy it on the cloud. And we will use Astra. So basically, we will use Cassandra as a service running, I guess, as most of you are on free tier, it's mostly probably going to run on AWS. But your application will be running on Google Compute Platform, and it's perfectly fine because you are free to choose whatever works for you and combine them as different bricks together, and that's great.
Exactly. Good. So this is what we're doing today. So DataStax Astra is Cassandra, as a service. You can work at a multi-cloud, multi-region. It can be, it doesn't have to. You're not locking in with a particular vendor, and it's just a good example of a software as a service in this context here of the application of this presentation. I'll let you handle this, Alex, if you don't mind, because I actually haven't really used the serverless functions very much.
Yeah.
So it would be great. Thank you.
So the idea is very, very simple. When could you switch one step back?
Sure.
Yep, perfect. So from containers to function as a service, or I would say better, from applications to management configuration to containers to functions as a service. So what's the trick? Take a look. With the platforms as a service like Heroku, maybe you know Heroku, some services of AWS, Google Application Engine and others, they provide you a platform for you to deliver the application, and this application will work and communicate with your clients. And in this case, you still have to take care about a lot of things about your applications, but you also has to understand what's going in behind the hood. And the second thing is when we go with some simplifications, we are moving on to container management. What's the trick? First, when you are working with platform as a service and your application mostly probably have some dependencies. So let's say you're working with Python and you need to have some Python packages. You have to install all of them, you have to take care of them, and you have to have them not only locally, but also at the platform you are using to deploy the application. Then container comes, and container, as you've seen, allow you to pack all the dependencies of your application together in a single package. For example, Docker image. There are some more tools and ways, but Docker is the most popular for now. So you pack the things into the Docker images, and then you can run it as a container everywhere on every platform which is just supporting containers, and you don't care about the dependencies anymore. And the last thing, but with containers and with Docker, with Kubernetes, you still think of the bottom of this platform you are using, you have to understand what that's Linux. There are some Linux functions and so on and so forth. So you are inside the operating system, and if you forget about that, you have troubles. And then final thing is like completely serverless, function as a service. You deliver something to the cloud, like Lambda, for example, Amazon Lambda. You deliver the function like a packet. Well, function is the best name. I mean, really like an application processing the data you give, and you don't think about is it Linux or I don't know, God bless, Windows, or maybe something even more special. Doesn't matter. You have the function, and this function will be executed when you call for that. So you don't care even about the operating system you are working with. And that's like the true essence of the serverless thing, the highest level of abstraction. You just think of functions like in your programming language, and you don't think of anything below. So that's, in some cases, very, very interesting approach. Although it's not the most widely used for now, because, well, let's say at this moment, it doesn't fit all the use cases.
So I actually have a question, if you don't mind, because as I said, I haven't used that feature much. Is there actually a repository of pre-made functions, like, for example, heavy analytical functions, or would that be something that you create yourself and then use it when needed?
So basically both, but the most widely spread use case is to develop your own functions. At least from my experience.
Okay.
Yeah.
Cool. Thank you. Thanks very much for. Actually, yeah, that was another thing that there are some best practices if you want to use them with our drivers. Can you talk to that as well? So it's not something that I've done, and if not, we might just deliver the content later.
Yeah, well, so today we don't work with serverless as it is, with function as a service, so I will try to be brief. We cannot feed 300 AWS services within a single workshop, as long as this workshop is not 1 week duration. So the main things, working with serverless, we create driver connection to the database outside of a function entry point. Why? Because if you do it within the function entry point, every time function is called, you will create a new connection. And if it's kind of a function you use all the time, 1,000 per second, yeah, 1 million times per second, when your Cassandra going to be unhappy because it's going to make too many TCP connections. It will be easier with Cassandra version 4, but as it's not finished yet, and most of you are going to be at version 3 or maybe DataStax Enterprise, it's definitely going to make some problems with TCP connections. Don't forget to be aware of a number of client connections to the database. So the same thing, you have to recognize the limits of the system. That's not about Cassandra, but more about Linux networking, first of all. But well, about Cassandra as well. Don't forget what it's a special runtime, so we have to consider query characteristics and think of it like running in a special conditions. We has to try to reduce startup time by disabling some things. So driver is a smart thing. Driver considers, when you start an application, your driver does really a lot of work under the hood. It connects to any of the seed nodes, lots of metadata, schema allocation, which node is responsible for which set of tokens, partitions, and so on and so forth. And as you could guess, this kind of startup may take really a lot of time. In some case, you may want to disable that because, well, otherwise your function will be just too slow. Another thing, disable the driver heartbeats, work with idle connections, because, well, obviously, that's not always going to be the good idea to keep the things working like the traditional way, because, yes, it's a special environment. Move the data access and business logic away from the function endpoint. That's a very often mistake when people start to put business logic into very weird places. And these kind of functions, they are not for this kind of workloads. So don't forget what you don't want your business logic to be in the function entry points anyhow. That's not the best practice for sure.
Okay, I think I'm beginning to understand what this could be used for. So you could point basically your function at the Cassandra database to get some data out, for example, processes in the function and write it back in. Would that be, for example, a use of the function?
Yes, that sounds pretty good.
Okay. Yeah. Okay. Yeah. Okay, cool. Thanks very much, Alex. I think you really brought it home to me today. So we're all learners, especially I. So thank you.
We all learn all the time. That's why we have a great team of people with very different specializations.
Yeah, thank you. That's wonderful. Okay, so I think I'm now moving into the more comfortable presentation for me, which is the demo, right? I think we want to get started with deploying the application in Google Kubernetes Engine. And we've basically split it into two parts. And between those two parts, there will be the MENTI. So, it won't be too long, and then you can do the MENTI again. But pay attention, because some of the questions will cover what we do in this first demo. And at first, we review our architecture again. So for those who've been with us for all these 8 weeks, you should be pretty familiar with the architecture of the application that we have. We basically have a UI, which we call Getting Started with Astra UI. It's running with Node and React, and it's communicating via REST API to the backend. And we normally use a Java version of the backend and a Python version of the backend. To be very honest, Cedric was on holiday last week and he's the Java guy. So I did the Python. I just did the example for Python today. You are absolutely welcome to containerize your Java application and deploy it the same way as we did it in week 6. I won't be showing that today, but this is the basic architecture. And then from the backend, we have various choices. We can communicate with Astra, or we can put it into another Cassandra installation for the, to keep the demo simple. We just do it with Astra today. If we have enough time, we can obviously go and deploy the Cassandra operator again and install the Cassandra database. But otherwise, I would say try it. Try it yourself and ask us if you have any questions. Also, a few words. I think we've said this a few times. This is an example application to just show how to connect to Astra. It's not really representative, probably, how you would want to write your own application. And we've run throughout the workshop into certain problems, like with uploading the credentials to the connection dialog and all these kind of things. In a real application, you would handle this very differently, right? You would not want to send your secret stuff over a post request in order to connect. But it's just a demo application, and for the purpose of showing you the different interactions between UI, backend, and the database. Okay, so let's go into the first exercise, and I'm going to introduce Google Cloud Platform for you.
Yeah.
And for that, let's split up. That's the wrong one. Oh, where is it? Has that crashed? Ah, there it is. Sorry. Yeah, there we go. So I put a long README together. We put a long README together here in the week 8 of the Cassandra Workshop series. First, check, because we often get so many complaints about a small font. Is this readable? And if not, shout now, and I'll zoom in a little bit more.
Or stay quiet forever.
Yes, it's your chance. I'll just quickly check Slack if there's any feedback. Sounds good. Okay, then. So let's go really into the beginning of Google Cloud Platform. I'll show you a little bit around what the console looks like, and I've also put a lot of screenshots in there. And as I said earlier, this is not something that you can probably join us right at the same time as we're doing this, because you will need to sign up this is to you. This is unique to you. This is with your. In this case, I signed up with my DataSnacks email address. And when you sign up for the first time, you will actually be asked to enter a credit card, right? So it's both for verification and also to enable billing. And you might feel a little bit uncomfortable about that. That is really entirely your choice. But ultimately, all the cloud vendors work that way, right? Ultimately, they're selling you slices of their infrastructure and their resources, and there is cost involved. It's not a free service, even though a lot of them have their own sort of free tiers or free offerings where you won't be charged, but still a credit card sign up is required. And when you start with Google Cloud, I think it's really nice. So I started 6 days ago with this account, and then you get a good chunk of free credits so that you can really experiment. It's $300. I live in the UK, so this was converted to £230. And since in the 6 days since I started, I've used up about £13 with my various experiments. And so, this didn't cost me anything because it's my free credit. But obviously, if that runs out after I've used up all the credits, or after you get a full year for this kind of experimentation, then you would have to pay, right? And I think it's something that you probably, while you experiment with the free tier, I think it's worth getting your head around this billing and where does the money go, and what costs and what doesn't, right? So I think it's important.
I hope now you start to appreciate Astra even more, because Astra doesn't require you to enter credit card data and just gives you a free tier.
Does give you a free tier with actually 10 gigabytes of storage, so it's actually quite generous. So yes, I hope you appreciate
we tried to choose the easiest cloud platform for you, and we tried to find anyone without requirement for your credit card. But sorry, there doesn't exist any, at least major, cloud platform for you to use without entering the data. But we may have to stay forgiving for that, because, well, cloud platforms are very often abused by free tier usage, and people are trying to, I don't know, mine bitcoins for free and then run away.
Actually, that is actively forbidden in the free tier as well, here in the free trial with Google Cloud. So it's actually in the terms and conditions, you cannot mine Bitcoin, right? So, but otherwise you're fairly unrestricted in what you use your credits for. And so this is when you first start working with Google Cloud Platform, you will be asked to create a project. So this is, and by default, it just created for me my first project. And this is the home page of the project, where you see what you currently use. For example, here's my project name, project number. Then I can go to the project setting. In this case, I have actually, these are the resources that I'm currently using. These are the 3 instances that were required in order to spin up my Kubernetes cluster. And then I'm using a storage bucket, and I'll show you in a moment why I'm doing that. And then, you have a lot of help, actually. It's really nice. Lots of really good articles, how to get started. And, for example, I will probably, after this workshop, create a cloud function and experiment a little bit with that and see whether I can connect it to Cassandra based on what I've learned today. So one thing that I've included in the README is, take control of your billing, and I'm going to show you that today. So you can access billing here, and so currently I have not incurred any costs because everything has been deducted from my free credits. So there has been absolutely no cost. But still, I was sort of like a little bit thrown by this initially. So where did all the money go, right? So I've used the money. I thought I was using very little. Where did it go? And I wanted to get a little bit more visibility. So I decided to set up a billing export, simply because I couldn't really get to the details, where it was. So I could see here that there's something here, something was built, but I couldn't quite figure out where, how much money and what happened. And for example, they forecast here that I will use 41 pounds over the, based on what I've used so far over August. So I wanted to understand a little bit better. So I set up billing export, and in billing export, you can actually export to a file. And then in this case, I've set it so that it every day it exports to a bucket, and that is like your S3 container. This is a bucket that I set up in the storage, and this now holds all the daily CSV files that I get from my billing. And to do that, you would go into storage. So storage, and there's your browser. And then you can create a new bucket. You can create a bucket. Bucket names are really funny. They have globally unique names. So if you were going to do, even if it was for your own project, if you were going to call your bucket workshop billing, that wouldn't work. So you would probably have to call it something slightly different, like workshop billing 2, or I think Cedric used workshop billing test. I wonder what will happen when we run out of names, but I think we're very far from that. So you can then browse your workshop billing buckets after the daily export. And you see here, I now have a lot of CSV files every day to look into them. And I think I have one open from recently that I looked at. This is very small, but it shows you a little bit that this is actually quite cryptic in, what is the date when this was incurred, what was it, so there are different services, bandwidth, forwarding rules, I got charged for forwarding, port forwarding, for example, I got charged for external IPs, and it's actually, these are, it tells you how long this was used, and what the total consumption was, how much measurement, and then how much was I charged, right? So not everything incurs a charge, and everything that is charged is very, very small at this stage, right? So these are really fractions of a pound. It goes down to very, very small fractions. But this is, I think it's good practice while you have the luxury of the free tier that you get a grip on the billing. So you understand what costs what and where does your money go. And you will actually find that the biggest components you see here, we are actually in already a quarter of a pound. This is for the compute engines. So this is here, for example, compute engine, the EC core, the RAM, the different VM images, they cost money. So that's something to bear in mind. So it's a lot of detail. I think don't skip it. I think it's worth staying on top of it so it doesn't at some point become a nasty surprise. And I think that's especially important also for AWS, right? If you do it in there. So I thought it was important to point that out. Set up the billing. You won't see something immediately. If you do the file export, it's every other day. It's the next day. So you would have to wait a day until you see some details there.
And that's important for every cloud because all of them are going to bill you. And if you do some mistakes, they can bill you very seriously. So I would suggest also to add a very simple approach. Watch your steps. Disable units you are not really using right now. For real, watch for that. Watch for that.
Exactly. Just watch it and just keep a good eye on it. And I think while you have this free trial, you can really look into this. But don't forget, and actually you need to refresh your browser sometimes here in order to see how this is actually going down in terms of, so it's not kind of this little bar that pops up. You see, it was 270 before, now it's 216, so it's going down. Just keep an eye on it. Do us a favor. Don't run into nasty surprises. Okay, good. So that was the main project, how to get started, how to set up the billing, how to keep an eye on it. Now we will use everything. The console is, you can have everything on the side, all the different services. And we will use the Kubernetes engine today. So let's go into that. And I've already set up a cluster for you, and which I've used for the last couple of days. I show you how to create a cluster, and but I will not create the cluster now because it takes time, right? So it spins up 3 to 5 minutes in order to do this, and we probably don't want to do that during the demo. But you would go to create cluster, and even that takes time. And it offers you sort of like a basic, you have limited options what you can create when you're in the free tier, actually, in the free trial. So I think you can have a maximum of 2 clusters, 2 Kubernetes clusters, and you have limited options actually there, how beefy your nodes can be that you want to set up. So I've not actually seen much of a possibility to configure that. This is the default setup, and it's actually a little bit more expensive than the very first cluster that they give you a setup here. So if you go on to create cluster, don't go with this one, just go to a very affordable cluster here to set this one up here on the side. So I'll show you again. So you, instead of doing create here, this will set up a more expensive default cluster. For our here, you can just click on create your very first cluster and create now. And this is the smallest one. And you see the differences here. It uses machine type G1 small instead of E2 medium, right? It has a smaller boot disk. It has less RAM. It has about half amount of the RAM that you get with the E2 medium. So it's a cheaper version, and it's plenty. It's plenty for what we want to do, right? So, however, if you want to run the Cassandra operator and deploy a Cassandra cluster, then go with the default cluster that uses the E2 medium machines, right? So because the very small one won't be strong enough for that, okay? And then you would click on create now. Actually, I can just show you what happens if I create this, because it's creating a second one now, but we will continue using this one in order to sort of like skip this. But this is what happens. You see it sort of spinning, and it takes a bit of time. And then after a while, we would expect to see exactly the same kind of resource allocation that you have here. We will get a 3-node cluster, and we have 3 vCPUs across the whole cluster. So that's 1 vCPU per worker node. And we have 5.1 gigabyte of RAM available for us. And as I said, that's not enough to run your CAS operator, but it's very enough for our purpose today.
Don't forget what today we run. Today we work with Cassandra as a service. Today we work with Astra. That's why we can use this pretty small cluster.
Exactly. So it does take some time to set up. That's why I wanted to stop. So I've prepared. Oh, I thought I had prepared this earlier for you, but this is expired. So I'm going to connect here. Using to connect, I'm connecting to the Cloud Shell. And then just click this run in Cloud Shell, and it's populating everything properly for you. So it's selecting my first cluster, what zone it is, what is the project, and you can run this in the Cloud Shell. And I'm going to put that into a new window. And is the font okay, or do we need
maybe one click bigger? But yeah, it's
okay. So you can do this and go to largest. Okay, that's the biggest that I have.
Okay, yeah, perfect.
Hope that's all right. Okay, now close this one down. So cool. Okay, so let's have a look what I got actually with this first cluster. So it's kubectl get nodes. And here, these are so you see how they're named. So GKE, Google Cloud, Google Kubernetes Engine, my first cluster 1, default pool, they're ready. And I actually don't see the master nodes here. These are all worker nodes. And I have this is the Kubernetes version that is being used here. And if I want more detail, I go to the -o wide option. oops, my typing. And now I see also the networking. So I see the internal IP, they all have the internal IPs, and I see the external IPs. We have a bit of a line break here because of the font size, but this is important. So everybody in Kubernetes has their own sort of like IPs in this internal network, and then we have the external network, the external IP addresses of those nodes. And if we want to later connect to our pods and our services from outside of the Kubernetes cluster, we will need to use the external IP addresses in order to address them. Okay? So, right. So what we want to do is we want to use our, we want to create a namespace, first of all. Let's start with that. And then we want to deploy our pods, as we did 2 weeks ago, into this Kubernetes cluster. So first, create a namespace. And we're staying with all the conventions that we've used before, so this is familiar for you. So we create namespace my app. Sorry. Oh. Okay, that's created. And then we want to create the various pods, right? We want to create a pod for the backend, and we want to create a pod for the UI. And in order to do that, we need to download images, right? We need to download the container images. And now, different to what we did before, we need to have those images available to us publicly, right? We need to download them from somewhere that's available to this cloud engine. And in our previous exercises, we loaded them ourselves into Kind. So they were available in this Kind cluster, and then we just loaded them from there. So this is a little bit different today. You have different choices there. You know, you could create your own repository now in this Kubernetes cloud, and you could load your images into this repository, and the pods would then take those images from there. Today we're using Docker Hub. So we've deployed, or we've pushed those images into Docker Hub, and we can actually tell you a little bit how we did that. Alex set up some automations in GitHub in order to automatically push the images whenever we make some changes to the code. And so they're available. I want to show you where they are.
Yep.
So
actually, if you want, I could show something about how it works and why it works this way. So I'm going to switch to my screen. Hopefully, yes. And now you watching at my terminal. So take a look. I have here a Cassandra Workshop series. Cassandra Workshop series. I hope you can see what's going on. Yes, that looks pretty great. And that's the Cassandra Workshop series, the repository we are working with at GitHub. So first I'm going to update it. So git pull, there should be no big changes, definitely. Last time I updated it tonight. Hey there, Git. Okay, good. So minor changes. Now I'm going to go to week 8. And we have some things here. So materials, information, instructions, and getting started with Astra Python, getting started with Astra UI. So web application, Python is a backend, UI is web interface. So we go to Python, getting started with Astra Python. And I will clear it up so we will lose nothing. And now I'm in this folder and I want to build an image. How do I do that? First thing we have to remember is Docker file. Docker file has the instructions how to build an image for Docker. So I specify the base image, I copy the current folder, I set a working directory, I install requirements, I open port, and I'm specifying the command to be executed when we starting a container out of the image we will build. That's a
stop, Alex. Very quickly.
Sure.
You need to zoom in.
Zoom in even more.
So yeah.
Okay. Okay. I thought I was big enough. Okay, so good. So that's a very simple Docker file to work with. Just few instructions. Now I want to build this file. So I'm going to do Docker build. I'm going to tag it. So this will be not just an image with ID, but it will be an image with some name I will be able to use, and I can call it like whatever. Hades architect. That's my login at Docker Hub. Test Python up.
It's still too small.
Come on. Okay.
I apologize.
Okay. I hope now it's enough. So let me clear that. Clear. So we are going to do Docker. So I'm calling for Docker. I'm saying Docker to build. I will call my application first. That's my name, my login at Docker. Oh, sorry. I have to change the size. Yes. And this name application will be test app Python. And I'm going to build it from the local file, from the Docker file in this directory. So I set the oh my god, dot. Never mind. I'm pushing enter, and oh my god, of course, Docker is not running. So I say Docker build, and Docker will build it for me. And then as soon as it's ready, I have to say Docker push to push this image to a hub.docker.com. What does that make? It pushes my image to hub.docker.com, and as it's a public repository and public image, every one of you or everyone in the world will be able to pull this image and run it. Okay, but then you see, every time you do any changes, you have to rebuild this image. Every time you do any changes, you have to rebuild this image. And if there is a command of 10 people working on this project, 20, you are going to rebuild this image every time. And when you push it and build it not in the best case scenario, but conflicting with some of your colleagues, there can be a real problems. So instead of doing it manually every time, which is a very wrong approach, there is an automation. There is a thing called continuous delivery. It means everything what you are doing regarding the delivery of your application must be automated and delivered, therefore automatically without your personal work on that. I don't see if my Docker machine is running already or not. Hey there, Docker. Docker is starting. Okay, so meanwhile, while my Docker is starting, I will show you something different. We go to DataStax Academy Cassandra Workshop series. Looks familiar because you spent last 8 weeks here. And here we have a nice tab called Actions. What's that? It's a GitHub Actions. And that's an automated builds for your application. So GitHub can build everything for you. There are very many different tools and different applications to make these auto builds. Some of you maybe know Jenkins, my favorite tool, a little bit old school, but well, still powerful. Some people prefer, how it's called now, what's the most popular here? So some people go to with GitHub Actions, but that's new. We have Circle CI, we have some others, maybe my colleagues will remind me. In general, there are very many different ways to build your app. And for this one, I have 2 builds configured. Docker build frontend master and Docker build backend master. Docker build frontend master will build Docker image for the frontend part of application. And Docker build backend master will build backend part of application therefore. And there are some builds and I can open any of them and watch the results. And I see, I guess I have to make it bigger again. Yes. And there are actions done by this build. And I can open any of them. Like first what happens when GitHub Actions starts, it's setting up a job, So prepares everything for you to do. Then it checkouts your repository in the current state. We worked with master branch. When it executes the command I give, so run docker build, blah, 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 blah. So build successful, and we are installing all the dependencies. And we log into dockerhub.com using some secret credentials. And finally, we push the image. The image will be at DataStax Devs CVS Week 8 backend. And it's done automatically. How it works? Very simple. In the Cassandra Workshop series folder, we have .github, workflows folder, and there are two files, build backend, build frontend. And if I open any of them, there's a very simple file. That's a special configuration file for GitHub, how to do automated builds. So just a name, well, whatever you want. In which situations, which build should be executed. That's a very simple example. That's not a production-ready example. In this case, I'm going to build that on every push to master branch. In your case, situation may be different. You may have some pull request, release on tag, and so on. But I want to keep this simple, simple. And then we have 4 steps. So it's going to be executed on Ubuntu latest machine. First step will be to check out the branch. Second step will be to build this image, and I explicitly write what I want to do. I want docker build, set tag, what I'm going to build. When I'm logging in to Docker Hub with Docker login, username, password, and then I push the image there if everything is fine. Those steps will not be executed if build fails. And usually, right here, you want to have some tests. We don't have tests for this image, but in general, that's a very good place to test the test. And now, I don't have to build things manually. Like, okay, my Docker is running, so now I can do this job on my own. I can say docker build, blah, 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 and it will pull Python Alpine image, do the things, install requirements, and I have to do it manually. And you know what? Good engineer is lazy engineer. Automate the things. Don't do the job manually if you can automate it. Very simple. Okay, and I will not show you how I push that because it's just docker push and image tag. But anyway, I don't have to show that because why? Well, GitHub now does it for me. Perfect, and it's free for open source projects. I love that. I'm done.
Cool. Hand it over back to me, and then I continue with the demo.
Just a second. I'm on that. Switching to you. Okay, now we see your screen.
Perfect. So actually, in the meantime, as you see, my second cluster has been created. We're not going to use it today. I just wanted to show you a little bit the process of creating this cluster. We're staying with this one here. And back to my Cloud Shell. And I hope the font is all right. I cannot go any bigger there, so I hope it looks okay. Right, so what do we need to do? Let's have a look at our README. So we explored the cluster, we saw the 3 worker nodes, we checked for the external IP addresses. These are different probably now that I've set up several clusters again and again. They change every time. Alex has showed you how to get these, how to build your images and push them to Docker Hub. And we're just going to use those, the latest ones. So this is the CWS Week 8 front end and the back end latest. And now we create, actually, I'm not going to create the YAMLs, but I've given you instructions how to create them. We're just going to use them, and I'll show you how to inspect them. So I actually have everything here. So this is these are the YAMLs that we use today. Perhaps not even all of them, because I did some experiments. And what is really nice in Cloud Shell, you can actually open an editor quite easily here and then explore them and edit them. And other than Gitpod, for example, this has autosave enabled. So let's remember what we need to do in order to launch our pods. So first, we need to have a configuration which has the environment variables in there. And we call this the config map. Is it this one? that looks good. So that looks like a config map that we can use. So we use the environment variable use Astra, and we're setting it to true. We want to connect to Astra. And the Python backend will only use this environment variable. It won't only use Astra. This might be actually a bit small. Am I right? So let's make this a bit bigger here. See what I can. Yeah, is that big enough? And then for the UI, we need to provide a backend address, a base address, and that will change. So we will populate that later. So what we're going to do now is we're going to start we apply the config map, and then we're going to apply the YAML for the backend pod, and then we will expose the backend pod so we can actually address it from external, and then that will give us the new base address. Then we will update this config map so that it's ready for our UI. And this is for the first exercise. In the second exercise, we show you a better way, right? So we show you the easy, way, just sort of like guiding you from where we were in week 6, where we used port forwarding. Today we use here something called a service called node port. But then in the second part of the exercise, we do it in a better way. Okay, so let's have a look here and apply this YAML. So can you still see this? I think I got out of here. So cube ctl -n my app for the namespace, and then apply -f config map to YAML. There we go. And that's applied. And now let's have a look at the backend YAML. So let's see whether we can make this a bit smaller here. I hope you can read it. So this is the pod definition that we used before. Again, these are the typical tags that we need to have in Kubernetes: API version, kind, metadata, and spec. The kind is a pod. We're defining a pod. Oops, this has the wrong one in here. Actually, we need to change that. So we're going to use the backend tag here.
What you are saying, sorry, I forgot to show it to you, but thanks, Bettina. So that's our DataStax devs repository at the Docker Hub, and that's where we store our Docker images, and that's the exactly. Oh, sorry, could you switch back for a sec? Oh, okay, yes, you can just put the. That's DataStax dev / Cassandra Workshop series week 8 backend. So that's exactly what is being built for us by GitHub Actions.
Yeah, and it's tagged with the latest tag, and I put that in there. I'm not entirely sure whether you need to specify the tag, but if you don't specify the tag, it will default to latest. So I just put that in there. So, and we will be serving on the container port 5000. And we've built our application this time to use the port 5000 again. Remember, in week 6, we worked around the fact that the 5000 port was blocked on the EC2 instances, so we built it for port 9090. But the default port for this Flask application that we're building is port 5000. We're staying with that today.
Bettina, I want to notice one important thing. Notice what in general direct usage of the latest tag, of the latest image of your Docker images is the bad practice. Because
is it?
Yeah, absolutely. Because take a look. Then you may release an untested update anyhow, and then you restart something, and then the new version will be pulled in, and then you may have some uncompatible changes, breaking changes of your API, and boom, your application in cloud is not operational anymore. So in general, good practice is to specify the particular version you want to be running right now instead of the latest. But currently we have only latest tag, and that's a demo application, so that's very fine. But for a real application, you don't want to have latest tag in the most of the use cases.
That's an excellent point. Thank you so much, Alex. That's brilliant. I'm so glad you're here. So with all your experience. Good, so let's close this editor and just apply this. So we have kubectl -n my app, apply -f, backend YAML. And there we go. We have the Astra pod, Astra backend pod is created. Let's check whether it's running. So kubectl -n my app, get pods, and it's running. This is very quick with the Astra pod, with the Astra backend pod. For the Astra UI pod, the image is a lot bigger. I think it's about a 1 gig image. I don't know why. It must be the various UI elements, and it takes a lot longer to create the container and get it up and running. So if you want to really check whether it's serving, so you can go kubectl and do the logs. So -n my app logs, and then you do the full name of the pod. There you go. So put that in there. And that's what we're seeing. This is the output from the Flask server. So serving Flask up, getting started with Astra, debug mode on. This is serving, right? So this is looking good. But now we cannot access it, right? We cannot test it. We cannot see it from outside. So what we need to build now is we need to build a service that allows us to expose this externally for external access. And a very simple service to do that is called a node port. And I'm going to show you that in a moment. So let's go to, so there's a node port here, I think. That's a UI port. Let's have a look, node port backend. There we go. So node port is a different kind. It's another, we have the same tags again that we have. Actually, we have them in a slightly different order as I would normally use them. I don't know where this came from. I probably copied it. So we have the kind, a service, API version v1. We have the metadata for it, which is just the name, the node port backend. We have the type. It's a node port. And node ports basically map pod ports to external worker node ports, right? That's basically what happened, right? So we're mapping the pod port, which is currently serving on port 5000, to a port on the worker node machine where the pod is deployed. And it has a reserved address range. I don't know exactly what the address range is, something 3000 up to 3000, I think 500, something in this area. And I just picked 30,355, because I'm serving on port 5000, something with fives in the end. Looked good. But what I also need in order to tie it to the pod, I needed to use Astra. I need to select a label that I've defined earlier in order to establish that connection. This service belongs to the Astra backend. And I'm doing this because of the selector with which I specify Astra backend. And I've defined this label earlier in my backend YAML. So here is my label, Astra backend. And now in here, in my node port, I'm using the selector to select this label. And the label can be anything, right? It can be anything. I just chose that Astra backend, but it can be my pod, name Bettina, or whatever, right? It can be anything. It just needs to match, right? It needs to match you selecting the label with the selector. And this is a mapping mechanism in Kubernetes. You will see the user selectors throughout, right? If you want to connect services with other resources.
Just a second, just to notice what in general, there are different ways to do this job and to set up this connectivity. So now we work with node ports, but there can be other options just for you to consider.
Exactly. So we do this actually in the second exercise. We do different things. There are actually quite a few different options, right? We have node ports, we have cluster IPs, we have ingress services. So there's different ways of establishing this connection from outside. And it's a frequent question, right? What is the best what is the best way? Node port is very easy to set up. That's why we thought we show you that. You can set it up for test. Previously, we just did it with port forwarding, right? We just forwarded the port with the port forwarding rule. The node port is basically very similar to that. It just does that. For production use, the big drawback of the node port is it ties you to the worker node where the pod is running, right? So if the pod goes down and it gets launched on a different worker node, then that binding won't fit anymore, right? So you need to specify a different IP address in order to address your port, and so something has to change. That's not ideal, right? Cool. So let's deploy that, and then we can see whether we can access it from the outside. So we do. No, let me just remember what it was called. I called it node port backend YAML. So kubectl -n my app apply -f node port backend YAML. And the node port is created. Okay. So now we can inspect it if we want to have a look at get services. And I think I need to be in the namespace. And oops, there we are, and you see it is a cluster IP, right? And now we need to understand how we can actually access it from the outside. Let's have a look, see what I'm just not losing my track here. So backend YAML. Right, so it's bound to this. So we need to look up now where we need to look up the IP address of the worker node where our pod is running. So this is what we need to do. And this is this kind of node binding that we want to avoid later on. So we go again into...
Yes, sorry, while you are opening that, I wanted to add why we try to avoid node binding. The point is, with a node port, this port will be opened on the particular node this pod is running. And this infrastructure is born to be ephemeral, and today your port is running on this node, tomorrow your port is running on another node. That's why node port is a thing like for special use cases. We show it just like as the easiest scenario, but we have something better for you in just a few minutes.
Okay, am I getting a bit slower actually? Do I need to speed up a little bit? I wonder whether we've got enough time. I think we have enough time. Right, so I wanted to just quickly check where is my pod actually running. So my Astra backend is running here on this node, GKE, my first cluster, one default pool, and then it has this unique ID, BMBJ. That is the node that it's running on. So now I need to check what's the IP address, or what's the external IP address of this one. So I go to kubectl get nodes -o wide again. And I'm finding this BMBJ. So this is the BMBJ here, right? And the external IP address, this is the external IP address here. So so if I try this now, and with the port of 30355, oh, it's not connecting. And you know why? Because I need to establish the firewall rule that this port is now accessible from the outside, because this is not a default port, right? This is not like port 80, which is by default open in a lot of deployments. But 30355, we just decided that, and there's no way that Google Cloud Platform knows that we make this open for access. So we need to establish the firewall rule. And so I've put that into the so I call the firewall rule test node port, and we need to run that first as well in order to be able to have the access. So it's creating the firewall rule. Takes a little bit of time to do that. Not hugely, but it's there, so it's creating it. And then try again, see whether that comes through now. Please. I think for the first access, it always takes a bit. Yeah, this is very small, but you see this is the very, very simple serving page that I've put in there so that we know, yes, we are connected. We are the Python backend API, and please connect me to Astra via the UI. So this is external access to the pod that is deployed. So it's going from my browser. I'm contacting the worker node, and the port on the worker node is mapped via the node port service to the pod. And I'm seeing the traffic that the pod is serving. Does it make sense? Perfect. So let's do the same for the UI. So we want to, we actually want to give this address now to the UI. So this is in the architecture of our app, which I continue to say it's not ideal. You probably want to do this better. But in the architecture of our app, this is how it works. We specify the UI in the config. We use the same config that we did before. We just specify the right port here, the right IP address and the right port, and we use this as the base address. So in the architecture of our UI, this is essential. We need to set the base address, and we need to set the base address to the externally accessible API address, right? So this is non-negotiable, the way how this is designed. And then we can we do the same for the UI YAML, right? So we again update it with the right images. So these were my test images until Alex came up with this wonderful automation there. So we need to put the right image in there.
Yeah, Alex is very lazy. Alex automates everything.
I love it. I learned so much. It's awesome. So we put that into here. And I'm still using the latest tag here. And we then need to reapply the config map, and so that the config map service basically has the config map element in Kubernetes has the right values that we updated, and then we apply the UI, and then we should be able to serve the UI. So let's do that here. So we do gap so that you can see what I'm doing. kubectl -n my app. Apply -f, the config map, and you will see something like reconfigured or configured, right? So because it's not the first time that we applied, we updated it, and that doesn't bother our backend pod, right? That's up and running, that's configured, that's up and running, and now we do the other one, kubectl -n my app apply -f UI YAML, and the UI is created. It takes a little bit longer, so because the image is quite big. So if I show you the pods, you probably will see something like container creating. There you go. It's container creating. It takes a little bit longer until this is up and running. And yeah, so. And then it will also take a little bit longer to serve it later. So now we need to do exactly the same thing as before. We need to create a node port for the UI, and we will expose the UI on a different IP address, potentially because it might be running on a different worker node. So once this is up, we will see where this is deployed. So it's up and running, and let's see where this is. This is now deployed on a different worker node. This is on the 7H07, right? So remember that, 7H07. But let's first create a node port. So the node port for the UI is here, and it's the same as before. It's just using a different port this time, right? So I'm tying this to the container port 3000 or to the pod port 3000, and I'm mapping to the port 30,333 in this case because of the threes. I'm using a different selector, I'm selecting Astra UI. This was the label that I had in my UI YAML. So Astra UI. So I'm again establishing this connection, and let's apply this node port. So let's get I think out of the. So qctl minus n my app apply f node port UI. There we are. That's created. Now we need to look up where it's running. So it was on the 7 or 7 whatever. So kubectl get nodes minus o write. We have here the 7, that's CB, this one, this is the one. So this is the one here. And again, we must not forget, I just put that in there already, we must not forget to set the firewall rule. So let's do the same as before. Set a similar firewall rule. We need to name it differently. There's the firewall rule. This time we're linking to port 30333, and it needs to have a second name because we cannot just add to the previous rule that we had. So we're exposing this port, and there we are. And now if I serve this does take a bit of, oops. What was the name again of the 7? This one, 217. And it could take a bit of time because it's a small machine that's serving. And oh no, it's fast. It's nice. Actually, it's up. And now you can just, I won't, in the interest of time, I won't actually show you now the connection to Astra. You could just put it in the same way. I can actually probably do this because the next step would be the MENTI, right? We don't want to lose you on the MENTI. So Alex, if you want to quickly set up the MENTI and reviewing what we've done so far. And then after the MENTI, I show you how to do it in a better way, right? So instead of using node ports, which has this obvious binding to the worker node in the next exercise, we will deploy our ports in a different way. So we will deploy them as deployments. So we don't have this detailed binding. And we will install services, load balancing services that use an ingress in order to route external traffic to the deployment, which then picks the right port. You ready to do MENTI, Alex?
Just a second. MENTI is behaving as usual.
But in the meantime, I show you just the connection to the Astra database. So test the connection. Takes a bit of time, which is a good sign because it means it's not immediately falling over with any course policies or address not found or refused ports. So we see that the test is successful. We can save our connection as before. Saving. And then we can launch a new journey. So hello, we are going to space. And we can then check in Astra whether it's actually getting there. KV user, KV password, use killer video. Oh, I think it's probably a bit small, but I just want to show you that we can see something. And select star from spacecraft journey catalog. That's what I always use. And there we are. There's our spacecraft. Hello. And we're going to space. Launched just now. It's working. Wonderful. Ready for MENTI?
I'm sorry, it's still loading. Could you maybe proceed with the next steps, and I will tell you as soon as it will be ready.
Okay.
That's the only thing I can suggest. Sorry.
Wonderful. That's brilliant. Okay, good. Right. So the next steps. So this was basically this was the first exercise in the README. I hope you should just be able to follow it along. And if you have any questions, let us know. As I said, don't forget to set these firewall rules, otherwise you won't be able to connect. Right. So in the next exercise, we want to remove the node binding, right? So so let's first clean up our space here. We have a clear namespace. We just delete the namespace. I've also put the instructions here to delete your firewall rules. You don't want to leave them open forever, right? You don't have to do the delete for them now for this next exercise, but we don't use them anymore. So it's good practice to clean everything up. So just clean it up after this is deleted. And okay. This was the node port, and you need to say yes. You could also clean them up via the console. So you can, I'll show you just quickly how to do that. In the console, you can go to VPC network, and in here you see your firewall rules that are set up. So you can also clean them up here. So these are various firewalls that are just there to support the working of the Kubernetes engine and the cluster, but here is the second one that I did here. So the test node port 2, and I'm deleting that now here. So we don't have that anymore. So there's two different ways. Actually, there's always two different ways, at least two different ways to do something in Google Cloud. You can always go through the console, but if you cannot remember the commands, you will almost always find a way to do it via the graphical user interface with the Google Cloud Platform console, like here. So let's go back to the Kubernetes engine. And we will actually use the Google Cloud Platform console a lot more for this exercise, because it's actually, I thought this is the real power of using this hosted Kubernetes service for us, because they made it so much easier in terms of I don't have to write the YAMLs myself. I can just use the services, how they've integrated them, and use it to create those necessary YAMLs for me and create those necessary services for me here. Okay, so just to show you a little bit what we're going to do next, we're going to use a different concept now to launch our pods. And these are called deployments. And here's a YAML deployment. I hope it's legible. Let me just see whether I've got any feedback. Alex, have you got any feedback whether it's too small? I don't know.
Nothing yet. Looks pretty good.
Okay. Good. All right then. So we have here a different kind. It's deployment. Again, we have the typical metadata where we give it a name. We call it Astra backend. But in this case, we're setting up a so-called replica set. We're setting up what is the minimum availability we want to have for our pods. And we have the opportunity, for example, to set up a replica set of 3, and that would mean Kubernetes, make sure that we always have 3 up and running, 3 pods. And I wanted to show you that, but the architecture of the backend doesn't allow that, I'm afraid. Because you know how the backend takes the credentials in order to connect to Astra? In this case, if I have more than one replica, only one of them has the credentials, and the other one say, hey, I don't know what you're talking about. I don't know anybody in Astra, right? So it doesn't work, unfortunately, with the architecture of our backend. But that shouldn't stop you from trying a different app where you might want to have several pods running that sort of like back each other up in case one gets overloaded or goes down or whatever. And then it's the health of the health management of Kubernetes that would recreate them in order to keep the replica set available for your deployment. Perfect. Okay, let's go on. Let's quickly do this. So this is the Astra backend deployment, as I explained, where we're setting only up one replica, which is our limitation because of the architecture of our app. But everything else is really the same pod definition that we used before, right? So we're basically telling it, spin up one replica of this port and use this container with this image and this port, and again use the same the config map. We actually do a different config map. In this case, I split out the config maps for UI and for backend in this case, because they should really be independent. So the config map for the backend is only has this environment variable, and the config map for the UI only has the environment variable for the backend and for the use Astra. Right, okay, so let's do this. We want to first apply the config map for the backend. Then we want to create the deployment, and then we will use the console, the Google console UI, in order to expose the deployment and create the necessary services so we can address them externally without having to use a node port. So let's do that. We go and apply the config map. Remember what it's called. The config map is backend config. So we go kubectl -n my app apply -f backend config. So that's should hopefully get created. Don't know. Oops. Oh, I didn't create. Of course, I deleted the namespace. So let's do this again. kubectl create namespace. My space key is a bit broken. My app. And then we can create the config map here. So, okay, there we are. It's created. And now we want to create the deployment. So we do kubectl -n my app. Again, that is specific. The deployment is specific to a namespace. And then we apply the -f. And in this case, it's the Astra backend deployment. So so that's created, and then we can see what's happening here. kubectl, I think clear the screen so you can see everything behind our heads. kubectl get pods in the namespace, my app. And you see that's already up and running. So this is now a different ending. This is not the name that we gave it, right? This is the name that the deployment gave it. And you might recognize that from the Cassandra cluster that we set up, because this works in exactly the same way. So the Cass operator created a deployment, and in the deployment we have the different pods, and so they have some auto-generated names at the end. So let's go to the console here and see how that actually looks here. So first, we see now that we have Astra backend. This is a deployment. It currently has one pods, and it belongs to the namespace, my app. And I can now click on this one, and I can choose to expose it. And this is I think this is so wonderfully made easy here. This is wonderful. So for example, you can do here to let others access your deployment, expose it to create a service, or I've always been doing it like this, right? So I click here on the expose, and then I say, okay, so I want to map it to the target port 5000, and it will create a service type load balancer, and it will create a service name, Astra backend service, and I am going to expose that now. And it's taking a little bit of time to set this up, because it's under the hood is basically creating the ingress rules, and it's also, this is mapping to port 80. So it's not creating any firewall rules probably for this access, but it's creating all the plumbing underneath in order to make that happen, that we can address it from external. So I'm running over a little bit again. I'm so sorry. I hope you have time and patience. And we also stay on a little bit after the workshop for all our Ask Me Anything sessions, so you can just ask any questions, and I'm sure Alex and the team in the background are collecting the questions that have been accumulating. Right, so now it's given us an external endpoint. So this is different now, right? It's different to the port that we had before, where we had to specify the exact port. This is just an external endpoint that links us to this pod now, or to the deployment, which then in turn links us to the replica set and to this one replica. And I hope it's going to serve. Please, what's happening? Does it take some time? I wonder whether I made a mistake somewhere in there. No, it's there. Wonderful. Again, so so we are actually now connected again. So it's different now, yeah? So we are not connecting to a specific port that is bound to a specific worker node. We've got our own IP address simply for this load balancing rule, right? For this load balancing service. And that now lives in the context of the service. So we can change the deployment underneath, and we can change the pods underneath. That won't affect this IP address. However, if we change the service and stop it and create a new one, then the IP address would change. So we shifted the binding to the binding of the ingress, right here, of the load balancing service, away from the actual deployment onto the Kubernetes worker nodes.
Yep. And notice when you work with pods directly and define your pods, you work very low level. It's good in the beginning just to understand the basics. So I do recommend you to work with the pods beginning in general. But if you want to have more instances, for example, of the same application, you have to go and manually create the things like that. And with the deployment, you may specify some rules. You may specify I want to have 5 instances of these deployment, and you will have therefore 5 instances for that. And it's great. So it's automated, already supported by Kubernetes, and you have to think of the services in deployments and replica sets in general, not in the pods.
Exactly. So now, while in order to we're running out of time a little bit, so I just started already. I updated the config for the UI with this new endpoint that we have, right? So that's the base address that we need to use. And I'm just applying the config now. So the UI config, oops, apply -f UI config. And then I will run a new deployment for the UI, and then I go through exactly the same steps. So I do a -in my app, apply -f Astra UI deployment, and create that. And as we have before, it will probably take a little bit longer until this is created because of just the size of the image. Oh no, that was really quick. Perhaps because we had the image already in there, so it's in there, the UI. And then we do exactly the same as before. We go to our workloads, and we see the UI is running, and we go and expose it. We map it to the target port 3000, and we expose it. We wait a little bit, and then we will be able to access it externally. And then we can do exactly the same things before. We populate our connection dialog, and we connect again to Astra. So not sure I need to show you that as well. But yeah, and that was basically it. So this is now our application is fully available. You can, if you want to, if you take a note of those while this is up, you should be able then to actually connect to this UI. Because it's fully available, right? So this is the new endpoint. And so this might take a little bit of time to load. Just depends on what it has to send over the wire. But then we should get the connection dialog up pretty quickly. And you should be able to try it out yourself. Just remember, this is being served by very small machines, right? So not a lot of CPU power. Not a lot of memory, so it might actually be quite easy to overload it. So, but then here, so this is KB user, KB password. I hope I didn't make a mistake here. And connect with the bundle and test the connection. Oh, I probably did the wrong password here, so that's No. Yeah, I felt my finger slipping when I put the password in. So that obviously would cause a mistake, but this is looking good now. It's connected. You can save the connection, and then we can again connect to Astra. And now we don't have this particular node binding, so it's slightly better practice. And that was it for today. So I think, Alex, what do you think? Should we just take 2 minutes break and then we come back online to answer any questions that might have accumulated? Actually, one quick question. I think I do Cedric a favor if I point this out here. Where is the... It's all in the presentation as well. I just was worried that I would run out of time. So all the different steps that we've taken. So if you want to review the presentation, everything how it's working is in the presentation, and the entire architecture, sort of like how we set this up. So I hope that will help you to visualize it and review it when you go through the various exercises. Okay. Just before we break, perhaps Astracathon, technically the deadline has now expired. 2 hours ago, 2.5 hours ago, we are absolutely delighted. We have received some submissions, and just if you really haven't, just send it through as quickly as possible. So hopefully that's still enough, and then we can take it into account and review it, and we will announce the winner next week. And next week we will have an Ask Me Anything session with everybody who is available at the time in that time zone, where we answer any questions that you want to, that are still burning after being with us for 8 weeks. Okay.
Yep.
And then certification voucher. I think the process might have changed. I'll quickly check and I'll come back to this. But anybody who wants to get a voucher will get a voucher. Just make sure that we know that you've attended the workshops and that you want to claim it. And it will be sent next week. Okay, good. So let's have a quick break, I suggest, and then come back and for the Ask Me Anything, and I will switch to Discord and take your questions from there.
Okay, 2 minutes break. Bettina, could you please switch to next slide? Yep. And
Let's
next slide.
This one?
Yes, perfect.
Yeah. Perfect. Perhaps you can put some music on, Alex.
I would, but I haven't prepared anything, so we can just have 2 minutes pause. I think it will be fine.
So I've switched to Discord as well, so we can see what's waiting there. So,
So I see no new questions in chat. So far, only thank you, DataStax developers, for wonderful workshop. Thank you, DataStax team. Thank you, all the DataStax developers. Has been a great journey of 8 weeks. Really appreciate the efforts taken for knowledge sharing. We want to say thank you to all of you because, well, it's a great experience to be here with you, and that's amazing. I will watch some more questions. Rajiv Soni, will there be a hackathon next week? So the time for hackathon by itself is over. So what we have right now is we accepted all the submissions, and now we will review them, pick the best. There will be some team of judges. I don't remember who exactly is going to do that. Bettina, it was Patrick, I believe. Patrick McFadden, Vice President of DataStax.
Yeah, and all of us, really.
Yeah.
I mean, like we're all going to look into this. Yeah, we might pull in some other folks, you know, to if it gets really tight.
Yeah.
But yeah, so we've got some great submissions so far. I can say that.
Yeah,
so,
definitely. So and next week we announce the winners.
So there's always feedback about the music. I think if you go to DataStax Accelerate, you will find an episode called DataStax Radio that has a lot of really wonderful database songs and tracks. So you can just check out the DataStax Accelerate page and have a look at the various episodes. And there was one episode called DataStax Radio. It's really hilarious. Lovely music, but it has also some technical training in there, so it's I recommend watching it. And I also want to say what Alex said. I think it's been an absolute pleasure working with so many of you week after week. You know, you've just been a fabulous audience. It's been a wonderful experience working on this workshop series, and thank you.
Yes, we do a lot of workshops, we do a lot of events. Before the 2020, it was mostly on site. And this year we stayed online. It was first workshop series, or maybe a course to say so. And it was really great experience. So we liked it a lot, all the team. So we will do it again. We are scheduling some things, and we will announce them very soon. As said, by the way, Bettina, as long as you are sharing your screen, could you maybe please show the Eventbrite page so everyone will know where to subscribe for the events?
Ooh!
I will help you. Just open Eventbrite.
Okay. I think I was on this actually yesterday. I remember this one.
Yep,
here.
and it's going to be DataStax. So, but you can simply open Eventbrite and find DataStax there. And there is a button called Follow. So you definitely should press this button.
This one.
Yeah.
That's this one. Exactly.
And you will get the notifications for the upcoming events we are very about to announce. Of course, we also have Twitter, also helps. DataStax devs. And another important thing is, again, as said, subscribe button directly under Bettina. If it's not pressed yet, make sure you will press it right now.
Now, cool. Okay, so let's see what else is there in terms of questions in Discord. I don't watch the YouTube comments while I'm presenting because I just get overload. But so I haven't seen any questions there. Hope I haven't missed anything.
Question is, can we also get few client challenges what you face as case studies? So, in general, you see, Amit, as we before were working mostly on site and traveled a lot, we also took care of, well, very many different stories but now the main place for us is this YouTube channel. You're mostly probably watching this video right now. And we are working to deliver very different kind of contents. It takes time because we don't want to deliver raw, unprepared content. And of course, it takes time to prepare a good one. But we are working. So we definitely have some very nice talks almost ready from the recent Cassandra Day China and Cassandra Day Russia. So we have some great speakers from very famous companies, like for example, for China it was Tencent, it was Alibaba, and so on. So like very huge companies, one of the biggest Cassandra clusters in the world. And there were very interesting use cases to share. So we are working for these talks to be translated to English and deliver it also at the YouTube channel as well. And some nice stories from Russia, of course, also very interesting. So yes, use cases, we are also working on that as well. And by the way, we have so many people from very different countries and languages here. I'm working to keep running Cassandra Days global. So we also will have Cassandra Days in different languages, and maybe you will be a speaker or definitely at least an attendee for the Cassandra Days. We will also announce soon. So far, the first contacts for us upcoming Cassandra Days are going to be in Spanish, Japan, Chinese one is done already. And there were some more contacts I can't remind right now, but it's again all to be announced at the Eventbrite, and all of them will be at our YouTube DataStax Devs. Okay, so our time is almost over, looks like. Do we have any more questions? I will try to scroll up. Maybe we have some of the questions I would like to answer from today's workshop, like in the voice. Regarding the environment for this workshop, if you want to do it again, so if you want to do the exercises, and we do recommend you to do exercises, it works much better. It puts in your mind, in your memory much better if you do it with your own hands. But you have used your GCP voucher already or something else. I don't know, you cannot use GCP. The instructions we gave for the Google Kubernetes engine will be very similar, for example, on the AWS Kubernetes. Well, not completely. There will be needed some minor adjustments, but it will work also on the AWS. And AWS gives you also a free tier for 1 year, so it may also fit for you if you cannot use Google Compute Platform for any reason.
And you know, just to be fair as well, that's why I brought this up again. I've been using it for 6 or 7 days now, and I've used 4 pounds, 14 pounds, right, of the credit. So I think if you want to set $10, $15 aside for a good, 2 days of exercise, 3 days of exercise, that should cover it, even if you've already used up your free trial. So just make sure you switch everything off again, right, at the end, so nothing keeps running and ticking.
Yes. Okay, so it's on my place 11:31. Bettina is in the United Kingdom, so it's 10:30, correct?
It is 10:30 and it's exam day, so I will go and check with my son whether he's actually passed his exams.
Okay.
So,
yep.
Thank you very much, everybody, to tune in. It's been a real pleasure. Have a great day.
Yeah, have a great day, and we will do more workshops for you. It was exciting series, so we are very happy to have you here. And well, next week will be no real workshop, but it's more about having fun, running Menti, and so on and so forth. One important thing for next week, we use it to have workshops on Wednesday and on Thursday. And that's today's the Thursday workshop. Same content, different speakers, but that's the idea, you know. For tomorrow or for next week, I'm very sorry. For next week, we are going to have only one meeting. For me, it will be Wednesday evening. So maybe a bit another time zone. And so see you next week. I hope it fits your schedule and time zone. I really hope. It will be shorter than the usual workshop. We don't need 2 full hours. We will try to do it quicker, and we will run some prizes, and we will announce the winners of the Astrakathon, show some nice code, and so on and so forth. Thank you so much.
Party. It will be a party.
Yeah, it's kind of a party. Okay, so we all have something to celebrate. Much effort and incredible team to work with. Thank you so much. And last song for you, and we are done for today. You are amazing, and thank you so much for being with us. Love you all. Ciao.